Good morning, everybody, and welcome to this joint presentation brought to you by ProVu and DrayTek. Next slide, please, Mihai. So it's fairly obvious how this works. If you've got any questions, just type them in the box at the bottom. You can hide the control panel that may be on your screen at the moment by clicking the small orange button to the top. We've got a team of techies in the background. We'll be answering questions as we go along. If we don't get back to you on this webinar, we'll get back to you straight afterwards, or soon afterwards, should I say. Next slide, please, Mihai. So your presenters for the day, that's myself, Richard Sutherland, in the middle. Mihai's got the bulk of the work. Mihai, would you like to say a few words? Just test your mic, etc. Introduce yourself.
Yeah, good morning to everyone. My name is Mihai Krisu. I'm a technical account manager for DrayTek UK and Ireland. I'm all working alongside Richard, and I will be doing the heavy lifting today, basically.
Lovely, thanks, Mihai. And we've also got Jason Pryke with us. Jason, let's have a sound check from you. Do you introduce yourself for us as well, please?
Guys. Yeah, my name is Jason Pryke. I'm a technical sales executive here at ProVu. I've also recently taken over the management of DrayTek within ProVu. So if you do have any questions or just want a little chat after the webinar, feel free to give me a shout, or I'll be happy to speak with you. I'm also going to be handling the Q&A section at the end.
Lovely, thanks, Jason. Next slide, please, Mihai. So just a positioning summary. So what we're going to be going through today, abbreviations and benefits, top tips on managing, securing, improving Wi-Fi coverage, VLANs over mesh, that's one of Mihai's favourite subjects. Finally, site surveys, managing devices via ACS. ACS is DrayTek's bespoke management platform. If you'd like to know more about that, just in the chat box, put a comment in there, ACS, and we'll get back to you. And just to let you know, we can actually give you 500 free licenses on the ACS. We do appreciate that we've got a very mixed audience here. There's obviously going to be some real tech people who are looking for tricks and tips, and people that are new to this technology. We've done our best to cater for everyone, so if it does get a bit techy and over your head, stick with us, and we come back to the more simpler stuff. And if it's not techy, the simpler stuff, techies, stick with us, because Mihai's got a load of technical stuff in there as well. Next slide, please, Mihai. So the webinar is being recorded. The guys at ProVu will send you a link, a YouTube link, after the event. As before, as we progress through the webinar, we'll answer Q&As as best we can. Sometimes you get flooded with questions, depends on the audience. As I say, we will get back to you if we haven't got back to you. Jason is going to pick out a few corkers at the end. And there is also a survey at the end of this. So when the webinar finishes, it'd be appreciated if you could fill in the survey for us. And obviously give us a 5 out of 5, because Mihai's worked hard on this. Next slide, please, Mihai. Agenda. So just to recap what we're going to be talking about: challenges you face, how to set up a mesh network, advantages and disadvantages of 2.4 and 5 gig, top tips on securing Wi-Fi networks. That's a big issue nowadays. Useful features you probably didn't know existed. There's some nice ones in here. Tweaking Wi-Fi for maximum performance. Tiny little things like putting an antenna horizontally rather than vertically. Any pictures you see, the antenna's pointing upwards, isn't it? Sometimes it pays to lay those things down. I'm stealing a bit of Mihai's presentation there. I'll give up on that one. Site surveys. A lot of people just run around plugging stuff in all over the place and hope for the best. Do a proper site survey, and it's going to work. We'll show you how to do that. VLANs over mesh, again, one of Mihai's favourite subjects, and centralised management, which is also known as DrayTek ACS. I can't see the messages that have come through, but if you've put in there for the ACS licenses, go for gold. Next slide, please, Mihai. Just a little bit about the background between ProVu and DrayTek. We've been working together now for 5 years. If we go back 5 years, not taking anything away from ProVu, but they were literally just box shifting DrayTek routers. Box off the shelf, customer address on it, ship it, and that was it, gone. We've come a long way in that time. ProVu can now configure a device with a hard config. So it goes out with a username and password on it, for argument's sake, plugs in, plays. If the user does anything to the device, you as techies can just get them to pin reset it, and it will go back to that default configuration that you sent it out with, knowing that you've got a working configuration. Next slide, please, Mihai. Challenges we face nowadays at home. Old buildings with thick walls, SSIDs from neighbours. Me, for one, I've got a dedicated home office in a back bedroom. In my front room, I get Wi-Fi all over the house, but the signal in my front room is stronger from my neighbour's house than it is in my own house. We'll show you some tricks and tips to cover those sort of things. Family wanting access to the internet, so you know, people working at home, kids are at home as well, they want to go and play Fortnite, use up all the bandwidth. We can show you how that you can make sure that those people that need the bandwidth for work get the priority over the kids. A lot of people nowadays have also got sheds in their garden, extending the Wi-Fi up the end of a garden to those sort of devices. The default router that most ISPs just doesn't cut the mustard for these sort of applications, and people are quite happy to put their hand in their pocket and fork out on DrayTek products to get exactly what they want, especially on Wi-Fi. Security, that's another thing that we're going to be covering off. How about when a friend pops around and asks for your Wi-Fi password, you give it to them without thinking, don't you? What you're actually doing is giving them access to your network, and they can get into everything on your system, courtesy of having that password. We'll show you in this presentation how to protect those sort of things. Next slide, please, Mihai. Offices and social areas. So we need more security with VLANs and different SSIDs nowadays. They also want different network speeds. So we've all been in a hotel where you log onto their Wi-Fi and it's absolutely useless, isn't it? Or their free Wi-Fi, should I say. You pay your $5 for the 12 hours and all of a sudden you've got blisteringly fast internet access. We'll show you how they do that. Next slide, please, Mihai. Outdoors, pub gardens, car parks, muster areas, home and garden. People expect Wi-Fi everywhere nowadays, don't they? A bit like your mobile phone, you just expect it to work. How about connecting two buildings? So that middle picture there, there could be a lease line running between those two buildings. They cost a fortune, quarterly rental, etc. You could do that with Wi-Fi, point-to-point Wi-Fi. We'll show you how to do that. You also may want to concentrate Wi-Fi in a specific area. So hotel, for argument's sake, they'll give you excellent coverage in the bar area, bar and restaurant, because they want you in there spending your money. Whereas other areas of the hotel, the Wi-Fi is weak. Again, we'll be showing you how to do that in this presentation. Next slide, please, Mihai. Mesh versus traditional networks. Now, nothing's going to beat a cable. You run a cable through a building and you know it's going to work when it gets to the other end. But sometimes it's difficult, too costly, messy. It may even not be possible. Grade 1 listed building, for argument's sake, you can't just drill through a wall. So with what we show you today with mesh technology, we'll show you how to get to those hard to reach places with minimal effort. Next slide, please, Mihai. And on mesh technologies, I'll just use the right-hand side of that graphic just to give a brief explanation of it. Mihai will go into more depth. But let's imagine you walk into a building and the first device or the first Wi-Fi that you pick up on is the mesh router, so the 2865 in this case. With traditional, or if you just use them as access points, as you walk away from that router, you need to physically lose the signal before your device will start looking for another access point. With mesh technology, what you do as you walk away from that router and get close to the 960C on the right-hand side there, when the signal from the 960C is stronger than the original one, it will drop and pick up the next device. Carry on walking, you'll pick up the AP903 as a signal from that gets stronger, all the way to the far end of the building, then you're on the 802. And if you walk across the building, you know, you pick up the 912C, and it's fairly seamless. If you're on a voice call, it will drop for a second, a bit like when you're on a mobile phone driving up the motorway. That's enough on that. Again, I'm stealing Mihai's thunder. So next slide, please, Mihai. Extending Wi-Fi coverage. So our core 3 devices there. So the little plug at the top looks great. I mean, you could plug that anywhere at home and it wouldn't offend anybody. The AP903, brilliant device, but not really for home use. And the bottom one there, the 9112C or the 960C, they both look identical, both look like smoke alarms. The key difference between the two, The 802 plug, if we use a hotel as an example, you couldn't put that in a corridor in a hotel. You know, some guest is going to pick it up and walk away with it. Whereas you could put the 960C or the 912 up on the ceiling, looks like a smoke alarm, nobody's going to touch it. More of that as we progress through. Oh, and Wi-Fi 6 there actually as well. The 960C is our first Wi-Fi 6 product. Next slide, please, Mary. Hi. We're going to get into some specialist coverage, so point to point. So again, the picture on the right, I mentioned earlier about linking two buildings together. That's the sort of applicant, you know, that's the sort of kit that you use for that. If you had, I don't know, a security office at the end, or you know, outside the building, you could concentrate the Wi-Fi, point the Wi-Fi into that building. Next slide, Mihai. This is just a page from or a snip from our website, draytek.co.uk. I recommend going and have a look on there. Anything that you want to know. So if you're looking for a specific router or a specific switch or an access point to do something, there's some really good comparison charts on there that'll answer all your questions. We've also got a new tool coming out in the near future where we'll ask you a range of questions, you tick the answers, and at the end we'll actually recommend the product to you. I think that's probably about 3-4 weeks away before we launch that on the website. Next slide, please, Mihai. And that's me. So at this point, I'll hand over to Mihai.
Thank you very much, Richard. And by the way, welcome to everyone to this presentation. We will now move to a more in-depth technical approach, and we will start with how to set up a mesh network by using the router as the mesh controller. So we therefore have this scenario, but I'd like to start by saying that a mesh solution is the best next thing available after an Ethernet or a completely wired solution. In this scenario, we have the router that is acting as the mesh controller, and the 3 access points that are acting as mesh nodes. And because the layout of the environment doesn't allow us to lay down Ethernet cables, as a result of this, we will be using mesh. So let's quickly jump into configuration. Logging into the router, and under mesh setup, we have to enable mesh. We can see the 2862 acts as a root role. Then we perform a search for additional nodes. After the search is complete, we found a node. We nickname the node, for instance, upstairs, and then we add the node to the mesh group by pressing apply. We then navigate on the left-hand side to mesh status. We will be seeing the upstairs access point as being offline, so it's trying to link to the mesh route. The next status is going to be amber, which means it's online, it's connected, but the configuration has not synced yet. And finally, when it's green, we know that the configuration has been pulled from the controller and the access point acts as a mesh node. Furthermore, if we want to add another access point, we go back to mesh setup. We check the mesh group. We can see the 903 that's added in there already, so that's part of the mesh group. We perform a search and we find another access point. We nickname the access point and we press apply. And checking the status, we should be able to see them all online with some statistics, the hop count, clients connected to each of them, and so on and so on. Now let's quickly have a look on dual band pros and cons. So wavelength distances, non-overlapping channels, environments where the 2 bands are fitting better. So let's start by looking at dual band, and I'm sure everyone knows, but I would just repeat myself. Dual band obviously refers to capable end devices that operate on both the 2.4 and 5 gigahertz wireless radios. But yeah, obviously that refers to network devices that can operate on both radios, such as access points or Wi-Fi routers. So if we look at the differences, we can easily see the wavelength difference between the 2.4 and 5 gigahertz. The 2.4 has a lower bit rate, but the wavelength can easily penetrate walls, since obviously it's much wider. The 5 gigahertz, on the other hand, has a higher bit rate, but the waves are penetrating obstacles with difficulties. That's why you get less coverage on 5 gigahertz when compared to 2.4, and higher speeds on 5 gigahertz when compared to 2.4. Now we have some non-overlapping channels on the 2.4 radio. So each channel on the 2.4 spectrum is 20 megahertz wide, and the channel is separated by 5 megahertz, and the entire spectrum is only 100 megahertz wide. So that's the channel width, basically. This means the 11 channels we see in there have to squeeze into the 100 megahertz available, and obviously we'll end up overlapping. However, we do have 3 non-overlapping channels on 2.4, which is channel 1, channel 6, and channel 11. Now, if we put this onto a live scenario, we can see on the graphics that we have a layout that requires 3 APs to cover the entire area, and both bands are required, 2.4 and 5 gigahertz. If we don't really need to worry about the 5 gigahertz band, in terms of interferences, of course, we need to worry about the 2.4, since it's a very congested band, and most likely it's going to result in poor Wi-Fi experience for the 2.4 clients. Well, to cover this area entirely without having the APs interfere with each other, we need to manually set the first AP on channel 1, the second AP on channel 6, and the third AP on channel 11, those being the 3 non-overlapping channels that I mentioned on the previous slide. But if we need to add a 4th AP on the network, well, nearby it's an access points, AP1, that can potentially interfere with the newly added access point. We know that the first AP was manually set to channel 1, therefore we will set this one to channel 11, in this way avoiding potential interferences. Now, if we move to the 5 gigahertz spectrum, if on 2.4 we had only 3 non-overlapping channels, on 5 gigahertz we have 19 non-overlapping channels, assuming you are using the 20 megahertz channel width. Those channels are grouped in 4 categories, basically. A lower, which is for indoor use, A upper, which is also for indoor use, B used both indoor and outdoor, and C, which requires a license to operate on. Now, as I've mentioned earlier, on 5 gigahertz, we only have the 5 gigahertz only uses, if we only use 20 megahertz as the channel width, we get to have 19 non-overlapping channels. If the channel width is set to auto on the AP, then the AP might try to bind some of these channels, which will result in less non-overlapping channels, but far higher speeds. As you can see on the graphics, on the 40 megahertz, we only get 9 non-overlapping channels. And it gets even worse further it goes, with only 4 non-overlapping channels on the 80 megahertz channel width. If you want to force the AP to only use 20 megahertz channel width, then under wireless LAN advanced settings, you can define that by selecting only 20 megahertz. Looking a little bit to Wi-Fi technology, the Vigor AP 1060C and 960C features Wi-Fi 6 technology, the latest generation of wireless, otherwise known as 802.11ax. For sure, it's backup compatible with previous standards, so older wireless devices can still connect, such as AC and I won't say more than that. Some other great features include WPA3, which enhances wireless security, BSS coloring, which improves interference handling, therefore making it much easier to install access points with overlapping coverage, and is less affected by neighbors' wireless traffic. That's a big one. Wi-Fi 6 also uplifts performance for both 2.4 and 5 gigahertz bands, giving better range of coverage. Related to Vigor AP 1060 only, which has a dedicated third radio for monitoring all channels for airtime availability, but not only for that, it also uses WIDS, or wireless intrusion detection system, that keeps checking for any rogue APs broadcasting the same SSID. Once that's detected, the notification can be sent to the administrator. Now let's have a look quickly to some wireless security and some tips about that. We therefore have I've described 6 steps to enhance your wireless network security. If you want to better secure your network, the first thing you should do is to change the service setting identifier. That's the name of your Wi-Fi network, which is also known as the SSID. This usually appears when you do a wireless search for available Wi-Fi networks. Use a strong and unique password, and also use only WPA2/PSK security method, or WPA3 mode. This is the newest security mode that I've mentioned earlier, but it's available on Wi-Fi 5 as well. And obviously supported on all our current access points, apart from the 802. Increase your Wi-Fi security by only using network encryption, which is disabled by default on the newly added SSIDs. So if you add a new SSID, such as work, that's going to have the security disabled, meaning that you need to go and add the password in there. Hiding your network SSID will, in essence, make the AP to stop broadcasting the network name, making it invisible when a Wi-Fi search is conducted. Doing this requires you to manually add the name and the password of the network on the Wi-Fi devices. Obviously, use a strong password for accessing the APs. And always use a different VLAN for administrative management purposes. VLAN that's not available to Wi-Fi clients. Let's have a look where we can locate the security settings on the 8 access points. So if you want to hide the SSID, like I mentioned earlier, there is where you do that. And on the wireless LAN 2.4 or 5 gigahertz security settings, you can edit the security mode accordingly. And at the top, we can see each SSID has its own security method. Let's quickly have a look to some useful features, such as MDM and the scheduler for Wi-Fi. So the Vigor AP can detect which kind of operating system a device is using. And by using this information, the AP can apply policies to either block or allow specific clients for specific SSIDs. For instance, block any device running unknown operating systems. Let's see how we enable MDM on a Vigor AP. Logging in onto the access point, under mobile device management, we have policies. And then we set the policy to block mobile connections, for instance. And then we apply that on 2.4 and 5 gigahertz on the targeted SSID. Well, what's going to happen? We have a network with 2 SSIDs, like earlier, the office SSID and the guest SSID. The office SSID was set to not allow any mobile connections. And if such device tries to connect to the AP, as a result, it will be blocked. The guest SSID, on the other hand, allows any type of connections as per the initial configuration on the previous slide. Now let's have a look to how we schedule Wi-Fi. This is really useful for home environments and office environments as well. The Wi-Fi scheduler or schedule profiles can be set to be active on specific dates and time. That's why it's called scheduler. Okay, so let's see how we set this up. Back onto the access point under applications this time, schedule. We have to make sure the system time is correct because the scheduler it's dependent on this. So if the system time is not correct, you can go to system maintenance, date and time, and set your NTP server correctly in there. If that's fine, we can then add a new profile. So let's see how we define the profile. So this is the SSID schedule. First things first, we enable the scheduler. We set the action to Wi-Fi down as the next step. Third step would be to set the start date, which it can be the same day you are doing the scheduler. Start time is going to be probably 10 p.m. Duration time is going to be 10 hours, meaning that at 8 a.m. The Wi-Fi interface is going to come back up. Then we set the SSIDs that we would like to apply the scheduler on. We set the how often to weekdays, and finally we select the days that we want that to happen. And now let's have a look on how can we deal with poor Wi-Fi coverage. The two most common types of wireless aerials are omnidirectional, so all directions 360, but it's not spherical, yeah, so 360 only, and unidirectional, which in essence it signals radiates one direction, for example 50 degrees in one direction. An unidirectional aerial, which beams its signal in one direction, will radiate almost nothing behind it. An omnidirectional signal is the donut shape, and you'll notice in the diagram very little signal strength is near to the tip of the antenna. Now let's take these patterns as an example. We can see the 5 dB aerial might have a vertical beam angle of 40 degrees, whereas the 7 dB aerial might have a vertical beam angle of 22 degrees. That's 50% less vertical beam compared to 5 dB area, meaning that people at the upper and lower floors will not get covered. So just to translate this, increasing changing the aerials to a higher gain doesn't mean it's going to cover the entire building. It means it's going to reach further. Okay, now let's have a look to band steering. Okay, so the main purpose of band steering is to divert 5 GHz enabled clients from the congested 2.4 to the less congested one, which is obviously the 5 GHz. Without band steering, we can see loads of clients connected to the 2.4 and just few on the 5 GHz. By enabling the band steering, all 5 GHz enabled clients will be moved across from the 2.4 to the non-congested 5 GHz network. Let's see how we do this. If you already have enabled 5 GHz band, try to enable band steering to redirect the 5 GHz capable clients to the 5 GHz SSID, basically. On Vigor routers and AP, this can be achieved by setting up a pair of the same SSID and the same password for both 2.4 and 5. So if you have done that, then you can go to band steering, wireless LAN 2.4, band steering, enable band steering. Then use the overload feature only in case you want the band steering to happen only when the 2.4 has reached an utilization threshold. If you want band steering to happen regardless of the utilization overload, then do not enable the overload feature. This is a tricky one. So request to send, clear to send. This is a mechanism to reduce collisions among stations, but by using this, you'll add more overhead. Therefore, by default, the AP will only send RTS when transmitting a frame that's larger than whatever is defined into the RTS threshold field. In a network having many stations apart from each other, you may lower the RTS threshold to several hundred bytes to implement the RTS CTC more often. Basically, this reduces the time required to transmit the frame and therefore reduces the probability that it will be corrupted at the cost of more data overhead. And if you are not sure what to do in there, just don't do it. Let's have a look at airtime fairness. When there is a mixture of clients that are using different speed rates due to their relative position from the access point, or there is interference, or is a significant difference in speed of transmission for each packet, this will result in slower clients taking a longer time period to complete the transmission. The end result will be that a significantly higher proportion of the access point time is used when sending packets to these slower clients. Let's have a look to this graphic. Without airtime fairness enabled, we can see on the example that the station A spends way longer to receive a packet, whereas station B requires only a fifth of that time to receive a packet. With airtime fairness enabled, the AP will spend the same amount of time with each client, resulting in a better Wi-Fi experience for everyone. It's a very simple thing to enable, so it can be enabled on both 2.4 and 5 GHz, and it's under wireless LAN airtime fairness. Also, sometimes we might need to adjust the antennas, and that will resolve our issue. Walls, ceiling, doors, and cabinets will all decrease radio signals. Remove the obstacles between the AP and the clients as much as possible. And note that a microwave oven, a cordless phone, or a Bluetooth device are also operating on the 2.4 spectrum. Thus, it will interfere with the access point. Let's have a look at some site survey tools using the diagnostic section on the access point. Again, typical site survey challenges will be walls, levels, obstacles, congestion, user types, so too much streaming, no streaming, size of the space, access to power, and obviously physical security. Firstly, when we deploy the 2.4 and 5 GHz, we should conduct an AP discovery that will indicate which other devices are nearby, network devices that are nearby, and which channels are those devices using in order to take a decision on how to set up the Wi-Fi network. So this can be done obviously on both radios. Going on the 2.4 and performing a scan is going to bring us all the access points and Wi-Fi routers that are nearby, and we can see the signal strength that's in between them. We can see which channels are they using, and we can take a decision further on. Performing a speed test could be a really useful feature when you are trying to find out where an access point can be better placed. If you are using mesh or universal repeater, then by using this facility, you can get a better understanding where the device can be installed on site. So back onto the access point, under Diagnostics, we have a speed test feature. If we perform a scan, that's going to give us the end result. Now, on the same diagnostic page, there is an interference monitor as well. So we discussed about that. Interferences loads on 2.4. So let's go to Diagnostics, interference monitor, and let's check the 2.4 spectrum on all channels to see the overload. So there you go. As you can see, a recommendation is given by the monitor to use channel 6. Not that that's available totally, no, but yeah, it's the one recommended. This is a very good case scenario. Basically, you aren't gonna get that in real life, so to say. However, if we move to the 5 GHz spectrum, we can see there is little to none interference, and therefore the recommended channel for usage is 112. Now, let's move to slightly more technical setup. Let's create some VLANs on the router. Let's create the trunk port on the router. Let's create the VLANs and the trunks on the switch. And then we assign the VLANs to the right SSIDs on the APs. This scenario is valid for multiple networks. So when you have 3 networks that come out from an access point, basically, or so. So this is the topology that we'll be using today. We therefore have 2 possible scenarios, this being the first one, in which all the APs are wired into the network, and one scenario in which only one AP is wired into the network. The rest of them are wireless. As you can see, the LAN port 12 on the router, it's our trunk port connecting to port 28 on the switch, and also ports 1, 7, and 23 on the switch have additional access points connected to it. And let's see how we do this. Because all DrayTek routers have a layer 3 switch component embedded into the OS, we can then set up VLANs, we can create subnets and associate those subnets with VLANs. We can do dynamic routing between these VLANs. We can tag the traffic as well for other layer 2 devices, such as switches and access points, to recognize this type of traffic. We can do loads with the layer 3 switch that acts as a router. So let's log in onto a DrayTek router this time and navigate to LAN, VLANs. And obviously here we have to enable the VLANs. And because we have done that, we need to place all interfaces on a particular VLAN. So if we enable VLANs, we need to do that. As you can see, port 2, 4, 9, 10, and 11, I placed them all on VLAN 0. And also port 12, that is my trunk port that has LAN 1, 2, 3, 4 on them, as you can see, and the tick boxes on the column, which indicates that's my trunk port. I have enabled the VLAN tags for the 3 additional subnets. I have left the first subnet as my administrative management subnet, so that the APs and switches are going to take an IP address from that subnet, so therefore I can manage those if I need to log in onto them. And the tags. The tags, it can be any value between 1 and 1096, if I'm not wrong. Right, good. So this is how you set up VLANs, and this is how you assign them to a trunk. Now we have to move to LAN general setup and enable those additional VLANs because they will be disabled by default. So therefore now we have 4 subnets, 4 networks, 3 of which are tagged, and 1 which is my management or administrative, let's call it, not management, administrative subnet. This is done on the router. We can now move to the actual switch. So logging in onto the switch, we need to navigate to switch LAN, VLAN management, and create VLAN. As you can see, I have created the VLANs that match the tags that I initially created onto the router. Yeah, so it's 10, 20, 30. And number 1 corresponds with the untagged traffic that corresponds again with the first subnet, which is my administrative subnet. After we create the VLANs, we can move to interface settings. So we can configure the interfaces. If you remember from the graphics earlier, we had port 17 and 23 with the access points on them, and the port 28 is the uplink to the router. Therefore, I will set these 4 interfaces as hybrid, meaning that it's a trunk plus an access port in case something goes wrong, rather than just setting us as a trunk. So hybrid, the PVID is going to be left as 1, and then we define the tagged VLANs, which we know are the 10, 20, and 30 coming from the router, and we have the untagged one, which is subnet 1 on the router, that's also coming onto the switch, and the switch will be able to recognize that traffic because we put a tag on it. Now this is done. The next thing is what else do you connect to a switch? It can be a PC, a printer, an IP phone. If we add an end device to the switch, the interface VLAN mode should be set to access. So let's go back to VLAN management, interface settings, and let's set port gigabit Ethernet to access, which means the switch is going to keep that port in the desired VLAN, but it will strip off the tag before forwarding the traffic to that particular device. I've set that to access, and I've edited the PVID. And as soon as I've done that, you can see the untagged VLAN underneath now. It says VLAN 10. It's grayed out, so you can't modify that. So this type of interface setting, it's associated with end devices, IP phones, PCs, printers. The access mode is only for these kinds of devices. Hybrid mode is for network devices, access points, and we have multiple VLANs that need to cross the switch, basically. Now, underneath the same field, we can see the port status. And obviously, port 1, which is one of our access points, our untagged only, we can see the port number 5, it's an access port on VLAN 10. And the switch is taking the tag off when it sends traffic to that particular device. Otherwise, the device wouldn't understand what that is, and it's going to drop the frames because, yeah, it doesn't read tags. The next one is 7, which is our access point again, 23, our access point and the uplink to the router. So everything looks correct. Now we can log in onto the access points and assign the correct SSIDs, VLANs to the SSIDs. So back onto the access point on the general setup, either 2.4 or both 2.4 and 5 gigahertz. We can enable those. We enable the additional SSIDs. As I said, the first subnet on the router, it's my management subnet or not administrative subnet. The access points are going to pick up an IP address from that subnet. But for wireless users, I have tagged the traffic. So I have the employees network, the management network, the guest network, and they all correspond. They have the corresponding tags from the router. Now, because we have, if you remember, I said by default, when you enable new SSIDs, the security is disabled. Therefore, you need to go to wireless LAN security and edit your security settings. Most likely, you use WPA2 or WPA3 /PSK. Just a quick mention about WPA3. Not all devices support WPA3, so if you only use that, you might find yourself troubleshooting some issues because, yeah, maybe even 3 years old devices, maybe 4 years old devices, they haven't got an update for WPA3, so they won't be able to connect to the network. Just to have that in mind. Yeah, so and they set the WPA algorithm to AES, and the passphrase that's the password you usually use when you connect to that SSID. Now the second scenario, in which we use VLANs over mesh. It's very important to mention that VLANs as a standard is meant to work over a wired medium, such as Ethernet. Therefore, it can't be implemented over a wireless medium in the actual form. And as a result of this, DrayTek came up with a proprietary solution that implements VLANs over a wireless medium, such as mesh. So let's have a look. We can see first access point, it's the mesh route, and it's wired into the switch, but the other two access points, because of the layout and the environment, they can't be wired. So we will be using mesh. But we have the three subnets and the three networks that we want to propagate as well. So let's see how we do that, assuming that the configuration for VLANs was already done. Going back to wireless LAN, 5 GHz and 2.4, both. We enable bridge VLAN to mesh. And then we go to, under mesh, to basic configuration sync or advanced configuration sync, and we select all, and we send it to the additional access points. And after you complete this task, you'll have three networks on the access points, separate networks.
Are you taking his drink of water?
Absolutely. Yes. Right. So were we centralized management? Yes. So let's have a look. What options do we have in here? We have few ways in which we can manage our DrayTek estate. We can use the central management facility available on the router, or we can use VigorConnect. That's a free available software, or we can use the cloud-based version called Vigor ACS, and I will be going through this a little bit more later. But to start with, router-based central access point management, that's what we are looking at. This allows the router to manage any access point connected locally to the router, to change its settings, upgrade the firmware, keep track of the status, basically. And for larger installations, you can have the router auto-provision the newly added access points to the network. So they are configured up automatically when plugged into the network. Bear in mind that our mid-range routers do support maximum of up to 20 access points as a management capability. We can also manage our switches in the same way. We can easily see the hierarchy of the switches. We can see on a particular switch on the port 11 we have a camera. We can see which private IP address. We can see the MAC address of the camera. So basically, full transparency from just logging in into the router and use the central management facility on the left-hand side bottom. And now, VigorConnect. This is good for remote management? Absolutely. It's intended only for DrayTek access points and DrayTek switches. And installed on a particular device on the network, you can discover potential DrayTek switches and access points. And as a result, you'll be able to manage them under this platform, up to 100. It's worth mentioning that this tool is meant to work on the LAN environments or over the VPN, and it's not going to work on the internet. However, you can still use this tool to provision your DrayTek estate with certain changes. Now, for a cloud-based solution that covers the entire DrayTek estate, Vigor ACS will be a better suited tool, meaning that it can be accessed from anywhere. And there is no theoretical limit on how many devices you can manage from there. You can use the platform for provisioning, feature that allows you to do certain changes globally, meaning that, as an example, if you want to change the admin password on all your devices at once, you can use the provisioning facility to achieve this. You can also monitor your devices, see the connected clients on the devices, and have a better understanding of which clients are connected to a particular network and for how long they did so, and what was the traffic usage. If a device loses its connection to ACS, then an alarm will be produced, and an email will be generated that will inform you about the current status of the device. Scheduled maintenance gives you the ability to schedule a firmware upgrade and apply the upgrades on all your devices at once at a certain moment in time. You can also schedule a configuration backup, or you can automate the configuration backup. That can be set as a cycle backup, for instance, every 2 weeks on all my devices. There are dozens of reports that can be created, such as LAN, WAN, traffic overview, hundreds, I would say. And now let's have a look on how we have this scenario again. So we want to put all these devices. We configured our VLANs, we did the wireless settings, the network is up and running. Now we want to manage it remotely by using ACS. So let's see how we put all these 5 devices on the platform. Well, you will just need the router for this process. Logging in back onto the router under system maintenance, DR69, we have to enable the service. Then we need to use the wizard on the URL. And why is that? Because if you can see at the bottom, we have a handler that's in there and needs to be added to the end of the URL. Obviously, we want to use HTTPS, and then you add the URL without W's or without ports if the 443 is the default port in use. After pressing OK, the URL populates, and you can see the handler at the back as well. We add the username and password that's specific to the network, so it's unique for your network. We change the CPE client to HTTPS, so we have outbound HTTPS encrypted, and now inbound from the ACS to the actual device HTTPS encrypted again. Underneath that page, we have periodic inform that has to be always enabled. Then we have apply settings to APs, but this is going to apply to switches as well. So yeah, doing that, we can enable this. We need to add the actual admin password of those APs and switches, so the one that you use to log in onto their GUI. We specify stun. It's very important because since the TR69 protocol doesn't have a built-in NAT traversal facility, we use stun for this matter. Stun stands for Session Traversal Utility for NAT. And that allows the clients to find out their public IP address, the type of NAT they are behind, and the internet side port associated by the NAT with a particular port. This information is used to set up UDP communication between the client and the ACS server. Just to make it simpler, any device that sits behind NAT, it can be a router, 100% switches and access points, you will need to configure stun. You can see onto this router, this is not behind NAT, so the stun is disabled. But the access points, I need to configure them with the stun server. And the ACS server acts as a stun server, therefore you don't need a third-party stun server. After we press OK, all the devices are going to be provisioned and sent to ACS. But before we do that, we go to management as well, and we make sure the internet access control is enabled for TR69, yeah, because this is the protocol used inbound. Now, after we completed this, we just can log back in, log onto the platform and have a look and manage our devices, check things, change things, and so on and so forth. Thank you very much. I will now hand over to my colleague Richard that I believe might have some Q&As, at least queues.
I'll tell you what, I'm gonna throw that one across to Jason, Mihai.
All right.
Yeah.
That's good. That's good.
Thanks, Mihai. Yeah, so I mean, I've got a couple of questions. Yeah, I mean, I'll just jump straight into it. So, presumably the 960C is backward compatible, you know, with 802.11 AC and DN. Are you able to confirm that?
Yeah, it is. It is, even with the older standards. So it is backup compatible. You have the option onto the wireless LAN general setup to see them all in there, meaning that they all work together. So that's not an issue.
Cool, that's great. Another one here for you. What is the maximum recommended hop count for these APs in a mesh?
The maximum hop count, if you remember the Richard's slide, it's 3. You shouldn't have more than 3 because decreases the bandwidth basically. As I said, mesh, it's the next best thing after a wired connection. So having 3 counts, I would say keep it to 2 if possible.
Sure, that's cool. Another one here for you. Are we able to set up auto reporting within ACS to a specific email?
Absolutely. There are hundreds of reports. You get report tasks, so you can set them up every week, every day, every month. It can be anything. So there's a wide variety of reports that you can create, basically customized as well.
Cool. And can you do like multiple emails for the same reports?
Yes, you can. You can, because you have the user management. Yeah. So yes, you can.
Cool. Okay. Another one here. What would happen if one of the AP nodes dropped off the network? Is there some sort of fail-safe?
Yes, absolutely. So it has an auto-healing feature, let's call it, in which the mesh is gonna reform again with the available devices. Of course, it's gonna take a minute or so until everything gets back together. But yeah, it has the auto-healing process indeed.
Yeah, sounds good. Okay. Probably the last one here. Which access points are suitable for outdoor use?
For outdoor use, we only have 2 access points, which is 918R and 918RPD. The later, I mean, if you want to power up a PoE camera next to it, I would recommend the RPD because it has PoE pass-through as well. Obviously you need a high power PoE injector for that particular access point, but you would be able to power a CCTV camera from it as well. So that's the only difference, the PoE pass-through between the 2.
Cool. Okay. I mean, that's probably all the questions we'll go over today. But I mean, if there are any questions in the chat that haven't been answered, obviously we'll come back to you individually on those, just to make sure everything's understood. But I'm going to pass back to Richard as well now.
Mihai, can I just chuck another question? Somebody's asked. There's lots of questions, guys. So if we haven't got back to you, we will get back to you after the webinar. When the access points are talking to each other, do you lose signal strength as you go through the mesh?
No, we also have an access point called AP1000 that has 3 radios, meaning that you can use 1 radio for only mesh. I know what the question is. If the signals, maybe I didn't understand the question, but can you repeat that actually?
Yeah, maybe I didn't explain it very well. You've got access point 1 and access point 2 and access point 3. So one's talking to 2, and because they're talking to each other, there's a little bit of you lose something in between, don't you?
Oh yeah, absolutely. Yes. There is a trade-off in there. That's why the recommendation is if you do that, keep the hop count to 3. It's not going to be that bad, so don't imagine. In my testings, I couldn't get a delay larger than 1 millisecond between the. But in the real life, you might experience sometimes slight delay. I believe you won't gonna notice the delay, to be honest. But the hop count is set to be capped to 3.
Okay, lovely. Thanks, mate. But that's about it, guys. We're 1 minute over the 12 o'clock that we aim for. So, Mihai, thanks very much. I can see you've done a lot of work putting that presentation together.
You're welcome, Richard.
Thanks, cheers, mate. Jason, thanks for your help as well. Much appreciated.
Yeah, thank you both.
All you people that have asked for the ACS, I don't know how busy Jason is today, but it'll be Jason who gets back to you. Just on those ACS and the free licenses, ACS licenses cost anything from £6 down to £3.50, but these are totally free. 500 licenses, routers, access points, switches, the whole lot. Grab it while it's there. And on that note, thanks to everybody and goodbye.
And
Yeah,
thank
thanks,
you
guys.
again, and thank you for your great feedback. Cheers. Bye now.
Cheers. Bye now.